Hello and welcome back to another Orange Coast College Mathematics video. In this video we're going to talk about the law of cosine. So what does the law of cosine say? Well, the law of cosine says if I have two sides, B and C, and the angle across from the unknown side, I can actually solve for that unknown side. Or it says if I have all three sides, A, B, and C, then I can actually solve for one of my angles. So when can I actually use the law of cosines? I can use it when I have all three sides or when I have side, angle, side. Now, how do we actually get these equations? Well, let's start off by drawing a triangle. And now let's look at an angle theta. So this angle theta really is angle C because it's across from side C. Okay, let's go ahead and drop a perpendicular line from the angle A. And I'm going to highlight this part over here in blue. Now, what is the height of this red line? Well, we have theta and we have B, so we know that this red line is going to be B times sine of theta. And what is this blue line? This blue line is going to be B cosine theta. So now, what is the other section of this line? And I'll highlight it in purple. Well, this whole thing is A. So if I just want this purple part, all I have to do is take the entire thing, being A, and subtract this blue part, being B cosine theta. So this purple portion is going to be A minus B times cosine theta. Okay. Since this red line was perpendicular to side A, we know that this right here is a right triangle. And so we can use the Pythagorean theorem. So C squared is going to be equal to the red line squared plus the purple line squared. So let's go ahead and write that out. So we have C squared is equal to the red portion squared, B sine theta quantity squared, plus the purple portion squared, A minus B times cosine theta, quantity squared. So let's go ahead and multiply everything out. So we have C squared is equal to B squared times sine squared theta plus A squared minus 2AB cosine theta plus B squared cosine squared theta. Now there's two terms that have a common b squared in them, so I'm going to go ahead and put those together and then factor the b squared out. And so we get c squared is equal to b squared times sine squared theta plus cosine squared theta plus a squared minus 2ab cosine theta. Now sine squared theta plus cosine squared theta is equal to 1. So let's rewrite everything. So we get c squared is equal to a squared plus b squared times 1, but we'll just leave it as b squared, minus 2ab cosine of theta. And remember, theta is really angle C, since it's opposite of side C. So we come up with one of our equations for the law of cosine. Now, finding the other equations is going to be pretty similar to this. So hopefully it doesn't feel like these equations are just being pulled out of thin air. Now, before we move on, let's check out a tip to using the law of cosine. Now, whenever you're using the law of cosines, if it's possible, try to find the largest angle first. So we should try to find the angle corresponding to the largest side. Once you've used the law of cosines to solve for that largest angle, then you can go ahead and use the law of sines without a worry in the world, because you're not going to get that weird ambiguous case where you might have two triangles. So with that, let's move on to number 1. Now, it's always good to draw a picture, so let's go ahead and draw a triangle. Okay, now that we have our picture, let's go ahead and see what we actually have. So we have a side, an angle, and then a side. So we have side, angle, side. So let's write that down. Now, what do we not know? We don't know what A is, but we do know what angle A is, and we have those two sides adjacent to it. So we can solve for A with one of our formulas. So let's go ahead and write down the corresponding formula. So we're solving for A, so we'll have A squared is equal to B squared plus C squared minus 2 times B times C times cosine of angle A. So now we have A squared is equal to 7 squared, which is going to be 49, plus 5 squared, which is 25, minus 2 times 7 times 5 times cosine of 35 degrees. This is going to give us A squared is equal to 74 minus 70 times 0.819152. And we'll then get A squared is equal to 16.6594. And then finally, A is equal to 4.08159. But the problem wants us to round to the nearest tenths, so A will be 4.1 inches. So let's go ahead and write that in. So we have 4.1 inches right here. Now let's look at what we have so far. We have 35 degrees and then all of our sides. Now, what angle corresponds to the largest side? B should be our largest angle. Now, we don't actually have B yet, so I'm going to use the law of cosines to solve for B before I try to use the law of sine anywhere. So, we have B squared is equal to A squared plus C squared minus 2AC times cosine of angle B. Now, because I want to find angle B, I want to get cosine of B by itself. So I'm going to add 2AC cosine B to the other side, and then I'm going to subtract B squared over. So we're going to have 2AC times cosine of B is equal to A squared plus C squared minus B squared. Now I'm going to divide both sides by 2AC to get cosine of B by itself. So we're going to get cosine of B is equal to A squared plus C squared minus B squared divided by 2 times AC. Now I want the angle B. I don't want cosine of B. So I have to get rid of the cosine. So I'm going to do arc cosine or inverse cosine to both sides, and that'll leave me with just my angle. So B is equal to inverse cosine of A squared plus C squared minus B squared divided by 2AC. Now, if you plug the appropriate numbers in, we should get B is equal to 100.4 degrees after you round to the nearest tenths. So let's go ahead and fill that in. So we get 100.4 degrees. Now, we could use the law of sines or the law of cosine to try and figure out our angle C, but we don't need to. We already have two of our angles, and we know that there's 180 degrees in a triangle. So we can just solve for C by taking 180 and subtracting our other two angles. And this gives us 44.6 degrees. And so we've solved our triangle. So let's move on to number 2. So number 2 says solve triangle ABC, where we have all three sides being 7 centimeters, 8 centimeters, and 12 centimeters. So let's go ahead and draw ourselves a picture. Okay, now that we've got our picture drawn, let's actually look at what we have. We have three sides. We have A, B, and C, no angles. But that is one of our scenarios that we can actually use the law of cosines. So, which formula do I use? Well, the tip said, whenever possible, try to solve for the largest angle, and that should correspond to our largest side. So I want to find angle C first. So let's write down the appropriate equation. We have C squared is equal to A squared plus B squared minus 2AB times cosine of angle C. Now I'm solving for angle C, so I want to get that alone. So I'm going to add it to the other side, and then I'm going to subtract C squared over to the other. So we have 2AB cosine of angle C is equal to A squared plus B squared minus C squared. Now I'm going to divide both sides by 2AB, and so we have cosine of angle C is equal to A squared plus B squared minus C squared, all divided by 2AB. Now I don't want cosine of C, I want angle C itself. So I'm going to take the inverse cosine of both sides. So we have C is equal to inverse cosine of A squared plus B squared minus C squared divided by 2AB. Now plugging the appropriate numbers in, we're going to get that C is equal to 106.1 degrees after rounding to the nearest tenth. So let's go ahead and write that in. We have 106.1 degrees. Okay, now that I've solved for the largest angle, it follows that the other two angles have to be acute angles. So if I use the law of sine, I'm not going to have some weird ambiguous case where I now have to consider one or two different triangles. It's just going to give us one answer. So let's go ahead and use the law of sine to figure out angle A. So we have sine of angle A divided by side A is equal to sine of angle C divided by side C. Now I'm solving for the angle A, so I need to get sine A by itself. So we'll multiply both sides by A. So we have sine of angle A is equal to A times sine of angle C divided by side C. Doing inverse sine to both sides leaves us with A is equal to sine inverse of A times sine of angle C divided by side C. Plugging the appropriate numbers in, we're going to have that A is equal to 34.1 degrees when you round to the nearest tenth. Now from here, I can use the law of sine again. It's a pretty quick procedure, but I don't have to. I can actually just do 180 minus the other two angles. So we get that angle B is equal to 180 degrees minus 34.1 degrees minus 106.1 degrees. This leaves us with 39.8 degrees. Writing these in, we have 39.8 degrees and 34.1 degrees. And so we've solved our triangle. We have all of our angles and all of our sides. So that's going to do it for this video, and I hope to see you in the next one.